This is Sudheer, working as an assistant professor in Department of Civil Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad. Welcome back to the series of the Fluid Mechanics course. Through this course, I am going to discuss about what are the basic types of viscosities and how do we express them in different units of systems, and what are the basic values for which we need to remember the case of the viscosities. So let us go ahead. So generally viscosity, it is a property of the fluid that is caused due to the cohesion, and also it may be defined as the interaction between the molecules which offers resistance to the shear deformation. Here we need to remember the basic word, that is offers resistance. So here we may say that some frictional force is going to be generated in the case of the viscosity. So higher the viscosity of the liquid, higher the frictional force, we can say that. So in other words, we can say how do we say that the liquid is having more viscosity? It is depending upon the ease in which flows. Means, for example, when we pour the oil on the floor, since the ease of the flowing of the oil is very less when compared to that of any other less viscous substance such as water. If you consider the water as an example, and when we pour it on the floor, it will move easily without any resistance with respect to the surface, provided it is not having any rough surface. But when we take the oil on the same surface, due to its viscous nature, it may not flow freely. So that is what it is going to say, that it is the interaction between the molecules which offers resistance to the shear deformation, So fluids with high viscosity, like as we had discussed, that oil deforms more slowly, means the movement of the liquid particles in the top of oil will be very, very slow when compared to the top other liquids which is having low viscosity. So more the higher the viscosity, and higher is the frictional resistance between the two surfaces that are in contact. And basically the types of the viscosities are going to be expressed as dynamic viscosity and as well as the kinematic viscosity. So these are all the journal terms which we are going to come across very frequently, that is the dynamic viscosity and as well as the kinematic viscosity. So if you are going to see about the dynamic viscosity, that is it is defined as the shear force, or simply we can say that the shear stress, which we can see in the formula tau, that is required to drag one layer of a fluid with unit velocity past another layer of liquid with a unit distance, So that is what we are going to say, that dV by dy, the rate of change of velocity with respect to the distance, the variation of the velocity with respect to the distance. So here the dynamic viscosity in mathematical expression can be defined as like mu is equal to, that is the coefficient of dynamic viscosity, mu is equal to tau, that is the shear stress, per the dV by dy, that is velocity, the rate of the change of velocity over the change of distance. So that is called as the coefficient of viscosity. So how do you come across this equation? Basically, we know that from the Newton's law of viscosity, that this tau is directly proportional to du by dy. So this tau is called as a shear stress, and the du by dy is called as a rate of deformation with respect to that velocity. So in order to remove that proportionality constant, we are going to say that tau is equal to mu into du by dy. As we are going to calculate the coefficient of viscosity, that is the coefficient of dynamic viscosity, so therefore we can say that tau into du by dy, sorry. So its units are being expressed as Newton second per meter square or in kilogram per meter second. So here we are going to say that that mu is the one in which we are going to express very frequently in terms of the poise. That is, 1 poise can be defined, or 10 poise is equal to 1 Newton second per meter square. So that is the case of the dynamic viscosity. In terms of dimensional quantities such as m, L, T, it is going to be expressed as m to the power of 1, L to the power of -1, T to the power of -1. And here on the screen we can see some of the values of the coefficient of dynamic viscosity which are going to be used very frequently here. Next one is kinematic viscosity. So here it is defined as the ratio of dynamic viscosity over the mass density. So dynamic viscosity over the mass density can be defined as a kinematic viscosity, and it is expressed as nu. Okay, and the units are generally taken as meters square per second, and the possible expression of the kinematic viscosity is Stokes. Generally, we are going to express that in terms of the Stokes, which is taken as 10 to the power of 1 meter square per second is equal to 10 to the power of 4 Stokes. 10 to the power of 4 Stokes, and dimension it may be taken as m to the power of 1, l to the power of -1, and t to the power of -1, and the values which we are going to use for the kinematic viscosity are being shown. For example, for the water we can say that 1.14 into the power of -6 meters square per second, which we are going to use very frequently. But here I suggest you that most of the cases the values will be given to you in the problematic part, and after that we need to use the same values. Further, if the values has not been given, we need to assume according to the standards. So for those standards, we are going to remember these values. So with that, we had completed the case of that types of viscosities like kinematic viscosities and as well as the dynamic viscosities. Now let us see a few examples of this regarding the
like, share and subscribe. Hit the bell icon for more updates.